This week, Lab TV travels to an Air Force research lab in Albuquerque, New Mexico, where scientists create cool little machines that are out of this world.
I always enjoyed science and math. I especially liked studying the stars and space. And so I knew all the way through high school and into college I wanted to do something that dealt with space.
And space looks a lot bigger than it used to, thanks to the Hubble Telescope. It sends amazing images back to Earth, showing galaxies that we never knew existed. These pictures help scientists understand our own solar system and the very nature of the universe. To peer deep into outer space, the Hubble telescope uses an infrared sensor named NICMOS.
When the Hubble was launched, it had an infrared sensor on it, and because the infrared sensor needs to be cooled, they sent up a big vat, and we call it a dewar, of liquid nitrogen. Problem is, it had a thermal short, which means it was boiling off faster than it was supposed to. And so in just a couple years, they lost the use of their infrared camera because they lost all the liquid nitrogen.
NASA turned to Erin and her team to help solve the problem. They designed cryocoolers.
A cryocooler is a mechanical device that allows us to cool to cryogenic temperatures.
Cryogenics is the study of very low temperatures, below -150 degrees Celsius. To get from Fahrenheit, our regular temperature scale, to Celsius is easy.
You take your Fahrenheit temperature, subtract 32, then multiply it by 5/9.
Scientists also like to use a really cool temperature scale called Kelvin.
Kelvin is used because it allows us to have no negative numbers for temperature. So the lowest temperature you can have in Kelvin is absolute zero or 0 Kelvin. With Celsius, you have negative numbers. So in order to convert Celsius to Kelvin, it's Celsius plus 273.
Cryocoolers can cool things down to 70 Kelvin. That's -203 degrees Celsius, or -334 degrees Fahrenheit. That's really cold.
This is a cryocooler. The cryocooler works by using helium gas. The compressor in the bottom has 2 pistons, which push the gas up into the tube. The gas gets expanded in the tube, and when gas expands, it cools down. It's sent back down through this little tube, back into the compressor. This happens about 60 times a second so that a temperature that we want to obtain is reached, and we can mount the sensor right here.
We're going to use a forward-looking infrared camera to show you how a cryocooler works. What you're going to see is blue being cold, white being hot. If you look at the tip here, you can see it's getting very, very cold. This is the active part of the cooler here. This is where we cool our sensors. The reason we do this is that when we're in space, objects are very cold. The colder we get our sensors, the more things we can see. Space is not empty. There is a lot of debris in space. This also allows us to look past that debris. We're going to show you why we use infrared. Now, if you look at me and I hold this balloon up in front of my face, you can't see me. But if we put it in front of the infrared camera, you can still see everything that we need to see. We can see through all the dust and debris in space.
Thanks to Erin and her team, the Hubble's infrared sensor is now perched on a cryocooler and working perfectly. It will be sending back great images for years to come.
We're the first ones to see these things, and we're the first ones to see them operate, and it's really neat to see a cooler like this. One just like this is flying right now in space, and I get to design it, I get to test it, I get to see it built, and I get to make improvements on it too. I get to actually use my mind and use my physics, and I have personally helped make the technology better, and that's really neat.
To find out more about the Hubble Space Telescope, cryocoolers, or other cool stuff, check out labtvonline.org.